Okay, we are now recording. We are live. And it's week 7. Hopefully you had a good break. I didn't. Had to do some silly admin that has put me way behind in my 3311 work. And now I'm moving house, and that's going to put me even more behind. Slightly annoying, but there you go. All right, so I've half auto marked assignment 1, and I've almost finished assignment 2. Assignment 2. Assignment 2. This transcription is silly. All right, so today I want to finish off what I was saying about triggers. I don't think I did any examples last time, so might be worth doing that. And then talk about stepping outside the database, but looking back in from a programming language, and in particular, looking in from Python. Well, we have a practice to set up. It's already set up. I'll be showing you how to do it in a moment. Ooh, all right. Nothing up my sleeve. There's a directory. Here's a Python script. I'll look at that in a moment. I didn't do anything funny except not typing Python 3. There, it ran. It printed some stuff out. There's nothing to set up. So Python 3 and PyChartPG2 are available on d.csc. If you want to set them up at home, that's your problem. All right, getting back to triggers. Triggers have an interesting semantics, just to remind you. So triggers can be run before or after what? Standard constraint checking. A before trigger could actually modify the tuple that's being changed. An after trigger, well, the tuple's already been modified. But the after trigger has access to the new version of the tuple that was modified by a potential before trigger. You don't often have both before and after triggers on the same operation, but there's no reason you couldn't. So if you're inserting a new tuple, obviously there's a new tuple involved. A before trigger could modify it. So now you could have a modified new tuple, and we'd run all the standard database constraint checking on that modified tuple. And then if there are any after triggers, that value is passed through to the after triggers. If we're doing a deletion, we've got an old tuple only. There's no new tuple, obviously. Deletion gets rid of a tuple from the database. It's prime. So it's just meant to indicate that potentially the tuple that we end up with at this point could be different to the tuple that we had at this point. As I was saying, the before trigger can actually change the tuple. So you say insert into, I don't know, students, John Smith, and if there was a before trigger, this would be a very strange before trigger, but it could modify the tuple being inserted. So rather than John Smith, it was John Jones, okay? So new prime would be John Jones, new would be John Smith. It's not the kind of that kind of transformation isn't really something that you probably do, but potentially making sure that the appropriate letters were capitalized in a name might be something that you do. So if you had John, lowercase J-O-H-N, and you wanted to capitalize that first letter, then your new prime tuple might be capital J-O-H-N, and then that would be passed through. All right, so deleting, if you're deleting, you've got an old tuple, can't really modify that, not much point because you're deleting it. It's going to be passed through to standard database constraint checking. And then if you need to run an after trigger, you can also do that, but you still be looking at the about to be deleted tuple. Postgres is interesting. I'm not sure whether I was planning to talk about it in this course, but Postgres doesn't actually delete the tuples straight away. It just flags them as being old and no longer accessible. Might talk about that later. All right, when you're doing an update, obviously the intention is an application where a before trigger for a delete tuple. Good question. Did someone ask this in the last online session? They might have. And I probably said I'll go away and think about it, but I haven't. Oh, yeah. Yeah, we'll have an example in a minute. So if one of the things that the trigger was doing was maintaining some kind of summary value somewhere. So say the deletion was to actually remove a student's enrollment from a course, and you are storing the total number of students as part of the course record, then the before trigger could go and reduce the number of students in the course record, reduce that counter. So we got an example precisely of that coming up. For updates, you've got the original tuple and you've got the new version of the tuple after the version that's potentially going to be in the database after the change has been made, after the update has happened. Well, you've got a new tuple here, you can modify that. And so you could have a modified new tuple that goes into the standard database constraint checking. You've still got access to the old tuple if you want to do comparisons, for example, compare the old tuple to the new tuple in some way. And an example of the kind of thing I'm talking about there, if you've got a company database and a person moves departments, you might, and once again, you're keeping a summary count of who's in which department, or how many people are in each department. You might be interested in reducing the count in the old department and increasing the count in the new department. So actually having access to both of those things might be useful. Right, so here's how you define a trigger. Surprise, surprise, create trigger. I didn't check whether you could do create or replace, but I suspect not. You can always go and look it up in the Postgres manual. You can define a trigger as an after trigger or a before trigger, and you can define it on a number of different types of events, like basically insert, delete, update. On a particular table, you can apply a condition, and if the condition fails, then the trigger function doesn't get executed. But if the condition succeeds, or if you don't have a condition, then the trigger function will be executed. If you've got a before trigger, you've got to return either old or new, and that goes on to standard database constraint checking. If anything goes wrong during the trigger, then the whole effect of either insert, delete, or update gets rolled back. So the database doesn't get changed. Whatever you were trying to do doesn't happen. Anyway, that's the syntax for defining triggers. All right, well, one thing you could potentially do with a trigger is implement your own foreign key checking. Imagine we got two tables here, R and S. S has a foreign key to the primary key of R. And what happens when we're fiddling around with S tuples? So in theory, well, potentially you could have two separate triggers, one for insert and one for update, or you can actually do it as a single trigger, and I'll show you how that works. But clearly what we're going to do, we're going to create a trigger. That trigger is going to check that the R value in the new S tuple corresponds to a tuple in the R table. So that's obviously what foreign key checking does. So let's have a look at these triggers. Right, so here's our tables. Here's creating a trigger. We're doing a before trigger, and notice that we're doing it on either insert or update. As I said, we could have done it as two separate triggers if we wanted to, but I wanted to demonstrate something else here. Oh, I didn't mention that before. This is going to, so if you've got an update which is going to affect multiple tuples, this is going to run the check _s _fk function on each of the modified tuples. You can actually set things up so that the system will make changes to all of the tuples that are required, and that's only relevant for an update or a delete because you've got a where clause there which might identify multiple tuples, and you can have the trigger function run once at the end of changing all those tuples, which is occasionally useful, but this particular one is going to be executed for each of the changed tuples. All right, so here's our trigger function. First thing about a trigger function, it returns a value of type trigger, which isn't really a value at all. And remember what we're trying to do here. We've got a tuple, a new S tuple, perhaps, or in fact, we definitely got a new S tuple, either one that's being inserted or one that's being updated. And what we want to do in that tuple, we just want to check that the R value in the tuple actually exists in the R table. And so we can easily do that with a query like this. Just do a select on R where the ID value is equal to the R attribute in the new tuple. If we don't find this value in R, then we have a mistake. Before the trigger. Oh, yeah, sure. I mean, the order of things in these examples isn't something necessarily that you do if you're trying to put this into a database. So I'm just going through things in the order that you kind of think about them. So you think about the create trigger. Yeah, I'm just getting to that. All right. So remember we talked about found last time was a special, if you like, variable, which indicated whether there were any results coming back from this query. And if there aren't any, it means that the R attribute wasn't found in well, whatever. All right. So the question is, if the select returns nothing, then is found automatically updated. It's updated either way. If you find nothing, then found is going to be set to false. If you find something, found will be set to true. Right. So the only error condition that we need to deal with is when this value here is not found in the table. In other words, we've given a foreign key which doesn't exist in the table R. All right, so let's just jump ahead to the real thing, to the successful case. So if we do find a tuple in R that has this value, then everything's okay, and we can return the new tuple and go on with whatever other kind of standard checking we did. In fact, we go ahead and we do another foreign key check. The DBMS would do that. So we're kind of preempting what DBMS is going to do. All right, so in the same way that found is a special variable, inside trigger functions, there's also a special variable called TG_op, which tells you what kind of operation caused a function to be triggered. So notice that we can trigger it either on an insert or an update. So inside the trigger function, it's useful to know which of those operations was the one that actually caused the trigger. So we can use this TG_op variable to check that. In this case, if we discover the failure has been during an insert operation, then we can just cancel the insert operation by returning a null value from the trigger function, and that'll terminate the insert. If the trigger operation was an update, well, we already had a tuple in the database, and we've tried to change its R value to an incorrect value. And so we don't want the update to go ahead. And so we'd return the old tuple. So the change that we're trying to make isn't valid. So we want the database to go back to the way it was. For these things here, I'm not printing anything, but you could, if you really wanted to do something like could do something like that, which would produce a message at the user, which is only really useful when you're doing things through PSQL. And similarly, you could do the same thing for the update. In fact, since you probably want to do it for both of them, it might be better to put it there. And you have to have a return. And I think all the branches in this function have a return value. I guess what you're saying is if you raise an error or something, then yeah, you might kill off the trigger function. So you wouldn't return a value in that case. All right, so that's kind of using a trigger to do foreign key checking, referential integrity constraint checking. Not particularly useful to do it yourself because database already does it before you. What would happen if you declare yes, it probably will get confused. I haven't tried to do that, but Postgres can be a little bit silly. If you use variable names that are the same as attribute names for some of the tables that you're referring to, it can get confused from that. New is a tuple, not a table. I mean, it's not returning a trigger. A trigger value doesn't really exist, but that's basically just telling Postgres that this is a trigger function. Yeah, declaring a variable called old or new, you're asking for trouble, basically, I would suggest. So don't do it. Or, as you may have noticed in some of the examples I've done, if I really need to have a variable like that, I declare it as underscore old. Which is obviously distinct from old. But we don't need it. Maybe, you know, and there may be some kind of trigger context where it's useful to have a local variable, but you can always think of a different name than old or new. All right. So that's relatively simple trigger. In fact, many triggers are relatively simple. Here's another example. So we've got a database where we've got classes and enrollments in those classes. And which are you talking the one I'm just looking at? Yeah. All right. Definitely it would be an example of an after trigger because we don't want to fiddle around until we're sure that these values here are valid. All right. So what we're doing here is, all right, we've got a standard sort of class definition. The class occurs in a room on a particular day, a particular starting and ending time, and there's a quota for total number of students that can appear in the that can enroll in the class. All right, Ian's question. The reason we return old instead of null, if it's an update, is that we've already got a tuple in the database and we just want to make sure that that's the tuple that remains in the database and it remains unchanged. Interesting question. What would happen if you returned null? I'm not sure. If you want to find out all these fine-grained details of the semantics of trigger functions, go and write one yourself. That one in the previous example would be pretty easy to test out. All right, so the deal here is we've got classes, they've got all the standard information, but we also want to know how many students are actually enrolled in the class. If we didn't have this, we'd have to work out the number of students in a class. We'd have to do a join between classes and class enrollments. Maybe not such a big deal, but there may be contexts where doing that kind of join is quite expensive and it's cheaper to have the number of students already stored. So we don't have to do that join. You know, if we were frequently trying to count the number of students, then maybe avoiding that join would be a good thing. All right, so number of students is related to the number of tuples that happen to have this class ID in them. So if we change the class enrollments, then obviously we've got to change the number of students in that class. So if we add a new student into a class, then we want to update in stu. If we try to insert what looks like a rubbish student into what looks like a rubbish class, we probably wouldn't want to do anything. The easiest thing to do here would be just to let the standard database checking handle this case, because it would discover that's not a valid student. Presumably that's trying to be a student ID, and that's not a valid class. So the insert would fail anyway before we even had to worry about it. If these are both valid, then we're adding a new student to a class, and therefore we need to update that. Similarly, we might want to delete, right, take a student out of a class, unenroll a student in a class, and they both look valid. So if we do that, if the deletion is successful, then we need to reduce the value of n students. And standard constraint mean okay. Yeah, when I'm talking about the standard constraint checking, yeah, I'm talking about standard things like checking foreign keys, checking primary key constraints, and doing all of the regular kind of constraints. If you say that a particular attribute has to have a value greater than 0, then checking that kind of thing. So it's a domain constraint. Oh, and the other thing I didn't put here was, what if a student moves from one class to another? So I'll assume that we have to deal with that case as well. So let's have a look at how we might do this. And once again, it's not in an order, and it's probably not complete SQL. What? Oh, yes. I think I know what I did wrong. It's called SQL. All right. So here's our tables. Here's the definition for the trigger. And notice here we're doing it as an after trigger. Oh, and I said insert or delete just, and I've handled the case for update, so I may as well. Oops, already said that, didn't I? May as well handle that case as well. So this trigger function is going to handle all 3 cases. The wah really got me. Oh, all right. So the trigger function, once again, we're using tj_op to check. And remember, we only get to this point if the values that were involved in our insert, delete, or update were actually valid and the operation has occurred. Now, the operation doesn't really complete until we execute this trigger function and then commit the change, insert, delete, or update. All right, obviously, what we need to do, if we're doing an insert, then we're adding a new student. So we've got a new tuple. That new tuple contains a valid class ID. So we want to update the students in that class, or the number of students. Similarly, this is pretty straightforward as well. We reduce the number of students in the class, and that would not be new class, it would be old class. And finally, if we're doing an update, we're moving a student from one class to another. So we kind of have to do both of these operations. So we add them to the new class. and we remove them from the old class, or rather, we reduce the number of students in the old class. And there might be smarter ways to express that, but that kind of makes it patently obvious what we're doing. Now you might say, hey, what if there's triggers on the classes table? And that's true, there may be triggers on the classes table, in which case these update operations here are going to trigger those trigger functions for the classes table. And there's, yeah, exactly. So if we have a trigger that triggers something else on another table, and then that triggers something on the original table, we can certainly end up in a loop, infinite loop. But I mean, potentially, you know, the triggers might ripple through the database, making all sorts of changes here and there. Is it possible with the triggers? Because, whoa, that's a long question. Otherwise, efficient is always well, I mean, I think you're harking back to what I said last time about assertions. So the SQL language defines assertions which can, actually they wouldn't do this. You can't have one operation triggering other operations in the database without using triggers. But so that's definitely one use for triggers. A second use for triggers is to implement the kind of assertions that I was talking about last time, where basically assertions are constraints that span multiple tables. So the trigger function will trigger after we insert and delete or update a tuple in the class enrollments table. Yes. Did we not want to check quota before doing it? I suppose we could. All right, thank you. We'd also have to check it if we were doing an update. That's true. All right. If well, in that case, we need to do a select, wouldn't we? And we need to have a local variable. Ooh. All right. So and we know we're going to get a result back here because we know that the class is valid. Otherwise, we wouldn't have got to this point. Select student from so do that. Oh, I so need that, don't I? So I could do this in the query. Well, anyway, I'll do it like this for the time being. We could actually do the check in the query and then just check. Why did you have to ask this, Maria? It's blown up the size of the function substantially. I'm sure there are smarter ways to do this, but I'll just I guess for the case of insert and update, I could have had a special thing to check to effectively do what I'm doing now. Do something like that. So the insert would fail and we print that message or a message, something like that, if the class was already full. And similarly with update, you could do a similar kind of check. In fact, you'd probably do the same check, except in the case of update, you could return old. But if I remember correctly, the return value from an after trigger doesn't go anywhere. So you don't really need to return anything, although down the bottom here, I've got to return new, which is a bit silly because in that case, we probably wouldn't want this to go any further. I can't remember what all the error messages are. I'll use error. I know that's not correct. We literally have no support for classes or anything similar. We do. Postgres is actually supposed to be an object-oriented relational database. Hence the name Postgres. Oh, yes. And your mention of ORMs will drive me mad. Exception. Oh, is exception a thing? Beauty. Oh, look, it's a keyword. It must be correct. Beautiful. All right. Yeah. So that would fail and we wouldn't even need the return. Ugh. Yeah, right. What a winner. Remind me not to use any of the incredibly slow applications that your ORM will produce. And the reason I don't talk about ORMs in this course is that this is a database course and object relational mappers try as hard as they possibly can to avoid dealing with the database directly. But that's what we're trying to learn. Do we still need to return null if you use an exception? Probably not. If the exception kills off the function, then the return null is kind of redundant. Yeah. All right, you could leave it out if you wanted to. But returning anything from an after trigger doesn't do anything, I think. Should we do this checking for update as well? Yes, we should. But it's going to get too long. I'm sure I could come up with a smarter way to do it. I could probably write a PLPG SQL function that took a class ID and checked whether it was full and just call that at this point. Why is this after insert? That's a good question. Oh, yeah, good point. I think the exception will kill off the insertion. The reason I made this an after trigger is I wanted to make sure that at least everything is valid. So we got a valid student and a valid class. But yes, you're right. So you can see this little word commit at the end here. That's where everything finally gets finished and we have a new tuple somewhere in the database. Should it be inch due greater than quota? Oh. No. I mean, if anything, it should be greater than or equal, but we should never get greater than, because this is exactly what this function is trying to prevent that ever happening. So if we try to do an insert and the class is already full, in other words, n_stu is equal to quota, then we should fail. Yeah, yeah. Then, like I said, the insert doesn't really finally happen until this point at the commit. So the tuple hasn't really been inserted. You can think of it as being provisionally inserted. Yes, exactly. What will happen? Yeah, the commit won't happen because you ended up with an exception, which will cause the whole transaction, will cause the whole operation to fail. Yeah, maybe. When I tried to add data using a copy, yes. The other weren't added either. That's perfectly normal. So the question was, trying to add data using copy statement, if any of the tuples in the copy are incorrect, the whole copy fails. So you don't get any tuples inserted. So it's a nice kind of example. You know, we've got multiple insertions happening, but potentially multiple insertions happening, but none of them end up happening because one of the tuples was incorrect in some way. That's kind of useful, a useful property of the copy statement, because if you, rather than using copy, if you were to do a bunch of insert statements, then some of the insert statements that were valid would happen, and maybe only one of the insert statements wouldn't happen. Now, whether that's what you wanted is an interesting question. But with copy, either everything you wanted to do will happen or nothing will happen. And nothing happening is a reasonable outcome if there's an error. But having a few inserts that worked and one that didn't may not be the outcome you wanted. But sometimes it might be fine for that to happen. It all depends on the context. All right, so we looked at that. Okay, what's the time? Yep, still got time. Okay, so we've played around with SQL queries. We've played around with triggers. We've played around with PLPG_SQL functions. We've even had functions that can return things that look like tables if you return set of tuple type. So that's all very nice, but it's all happening inside the database. If we actually want to use a database in an application, then we need to be able to access the database from the programming language in which we are writing our application. SQL isn't a programming language. It's a data retrieval language. PLPG-SQL is a programming language, but it's all happening inside the DBMS. So it can't really interact with a user. Whereas that's what we normally want. So this is what we've been playing around with so far, and you can throw SQL into the mix here if you want. Everything's happening inside our Postgres server. Now what we want to do is step outside the Postgres server and run programs that interact with the database via the server. And the normal way this interaction happens is that you send an SQL statement to the database, and even if you've got an ORM, deep down within that ORM, it's going to generate a piece of SQL, which is sent to the database. So it runs the SQL query, perhaps, and then returns a bunch of results in the form of tuples, which have to be interpreted by the program. Now, before you can do these two things, the program, which remember is external to the database, has to convince the database that it's allowed to access the data on disk. And so there has to be an initial authentication step where you say, hey, I want to interact with database XYZ. My username is Jas. My password is blah, blah, blah. Am I allowed to do that? Thank you. And if Postgres says, yeah, you sound like a legitimate user, then it will send back an authentication or a connection record, which then allows you to interact with the database. Yes, you're allowed to define your own list of users in Postgres if you want, because you are the super user for your database. And that's the reason why you've got that hash in the PSQL prompt telling you. If you weren't the super user, the PSQL prompt would have a greater than rather than a hash. Yeah. Yeah, all right. So now we've got two separate entities. We've got the program running over here. It's interacting with the database server running here. Two separate processes communicating. So in order for them to communicate, we need some kind of API. And here's an imaginary API. We'll talk about a real API in a minute. But all of the APIs, whether you're talking about Java, whether you're talking about PHP, Ruby, Python, Perl, they all have a low-level access to the database, kind of like this. Some people think, is the DB connector library for example of Python import? Yes, you have to import Psycho PG2 to get a hold of the library. But generally what happens is that you specify, here I've done a very simple authentication string, just the name of the database. If it's successful, then I get back a handle. You know, this is, to some extent, it's a little bit like fopen. You know, if the file exists and if you can read it and you're opening it for reading, then you get back a file star, which you can then use to interact with the file. Right, but you get back this handle, which allows you to interact with the database. You can set up a query You can invoke the query. There'll be some kind of mechanism for doing that, which requires you to say which database you want to send the query to. So like I said, that is a handle or a pipeline, if you like, down which you can send a query. And normally there'll be some kind of, once again, it's kind of like a file star handle within a file star handle, and it gives you back a handle on the result set, and you can iterate through the set of results using some kind of looping structure. And once you get back a result as a tuple, you then need to be able to extract the individual components from that tuple. So like I said, this is an imaginary language, but they all look kind of like that. One important thing to note is that the initial connection to the database is a very expensive operation, and you don't want to do it too often. The Python program and DBS live in different places. Yes. Yeah, sure. It probably would matter. But so this is Jimmy's question about what happens if you run your Python program to access a database in London. Sure, there'll be some latency, but none of the stuff we're doing involves that. So the Python program is running on d.csc. Your Postgres server is running on d.csc. So there's no serious latency. But there is a cost in establishing a database connection. There's also a cost in sending a query to the database. So you don't want to do that too often. And the other thing about this is a lot of database interfaces will allow you to open the database, and they'll hold the handle to the database in a cache. So the next time you come along and try to open the database, because it's already opened, you don't have to pay this significant penalty. Sending off a query is also relatively expensive because you're communicating between your Python program or whatever, your Java program, and the database. You're sending a string. So Python 3, yes, is available on d.csc. Oh, what happened there? All right, so invoking a query is relatively expensive. Fetching a tuple from a query is super cheap compared to these other things. And it's actually probably a lot less than a millisecond. And despite what it said in the slides, I think it's quite fast. Now, doing this means you don't want to keep opening the database all the time. Once you've got it open, it's nice to keep it open if you're doing lots of interactions. This number here, 200 milliseconds, means you don't want to be asking too many queries. And I've got some examples coming up to show silly ways that you can deal with the database, resulting in inefficiency. And it wouldn't surprise me if many ORMs do things like this. Ooh. All right, so here's an example of poor use of the database. Once again, I'm using this imaginary interface. So I want to find mature age students. I've got 10,000 students, but only 100 of them are really old. we're over 40. Doesn't sound that old to me, but probably sounds old to you. Right, so we fetch all the students, we read them in one at a time, and we check whether the age is greater than 40. Okay, it's going to give us the right results. We're going to find all of the mature age students, but we read all of the tuples in order to achieve this. And most of the tuples are, I should have had 9,900 there, are irrelevant. So why do we want to fetch all those tuples and then do, fetch them into our program and then have to deal with them in the program when we know perfectly well how to fetch just the relevant tuples from the database by using a where clause, all right? So if we write the query like this, then the only tuples we get back are going to be the ones that we're interested in. We don't have to check. And we ask a single query. We did that before, but we only have to do 100 tuple fetches rather than 10,000. That tuple is almost as old as the old, whatever. Right, so clearly this is a lot more efficient than doing it the other way. Even though tuple fetches are relatively cheap, you still don't want to do 10,000 of them if you can do 100 of them, because you asked a sensible query and let the database do the work. Let's have a look at an even worse example. So we want to get a list of students, and for each student, we want to get the marks they got for all the courses they've taken. So it's kind of, a transcript for everybody all in one go. All right, so a way you could do it is get a list of students. And that query will do that. And then you can iterate through the list of students. For each of those students, we could run a query to fetch all of their marks. And we could do that like that. Notice that we are interpolating in a very naughty way the student ID. In fact, this is not so bad because this value here has been generated from a query that we ran on the database. So at least it hasn't come from outside. So this kind of interpolation into a query or forming a query by string concatenation is tolerable, just tolerable. All right. So basically we got nested loops here. So we're going to have to iterate over all students. For each student, we're going to have to run a query, and that query is going to fetch, maybe 8 tuples or so. So the individual queries aren't expensive, but the fact that we're running 10,000 queries to get student marks plus the one query to do the outer loop is real bad. So if we assume 10,000 students, each student has 8 marks, that's the number of tuples that we're eventually going to fetch. But this is the thing that kills you. 10,000 queries, each query costs to set up. So the whole thing is going to take a lot of time. So we got a simple select query here, simple select query here. Why not do a join? So here's how we should be doing it. So we can collect all this information. from joining the student table to the marks table. I didn't really say what the schema was, but let's assume that this join will work. Still ordering by student ID. And for each student, we're going to print out a list of their marks. So one thing we're going to have to keep track of here is if part of the deal was that we printed out the student name and student ZID and then printed all their marks, we'd have to keep track of when the student changed over. So this is going to give us all students and all their marks for each student, but in a giant list. So the nice thing about this is we now have a single query. One query, we still got to fetch 80,000 tuples because that's the number of tuples in the solution. I'm surprised Jimmy hasn't pointed out, but these tuples are bigger than the tuples in the other example. So maybe that's slower. It's not, trust me. Doing things this way is really, really, really bad. Why does DBNext only fetch the tuples, doesn't return all the tuples as an array? It could, and that's effectively what Python does. Either way, you're iterating over the set of tuples. Whether, I mean, we don't actually know what happens here either, do we? All we know is that we have run the query and somehow we've got something that represents the results of the query. Now, maybe what we've got in results is a giant list and we iterate through that list using DBNext. Oh. All right, so that's enough talking about poor usage of the database. Let's have a break until 5:10, and then I'll talk about PsychoPG2 and how you use that and Python to interact with databases. All right, I am about to pause. Okay, I'm back from the break. Yeah, so Maria's question, how do we know whether the result set is a list or of dictionary, or did you mean or dictionary, or is it a dictionary? It's a list defined by PsychoPG2. In fact, it's a list of tuples, Python tuples. What happened to, I don't know, and I don't care. PsychoPG2, what about PsychoPG1? You spelled psycho anyway, it's not spelled like the real psycho. All right, so PsychoPG2 is a library that talks to Postgres from Python programs. And it's relatively small. I don't think I've got everything here, but you start out by making a connection. You have to give a, what? You have to give a connection string, which could include username and password, but in our case, all we have to specify is the database name. If you've installed PostgreSQL from binary and you happen to have at home and you happen to have usernames and stuff, then you may need to put extra things in your connection string. All right, so once you connect, you've got a connection to a database, you can close it. Beauty. There's an operation commit where any changes that you've made up to that point will be fixed in the database. Very important concept is a cursor. You can create cursors. Cursors are things that you use to directly interact with the database. And one thing you can do with a cursor is you can execute SQL statements, and you can interpolate values into those SQL templates, if you like, if you want to call it that. If you're not sure what the hell execute is doing when you give it SQL template and a bunch of values, then you can use a function with the delightful name mogrify, which will produce the string that execute would have sent to the database, and you can print that out. So basically you can use that for debugging. Python has a number of different ways of fetching stuff. You can use fetch all, which will give you back a list of tuples. You can fetch a single tuple if you really want, and that'll give you back a tuple. And I think you can call that multiple times until you run out of tuples. And you can also fetch a certain number of tuples. So if you want the first 5 tuples, you can do it like that. And I'm sure there are other functions that you can discover by having a look at this, the PsychoPG doco. I don't know which version we actually have, precisely which version, but maybe. Oh, there's transmogrify. That means something. Anyway, there's documentation that you can access. Ooh, I don't know if I've put a link for it. I should. All right, somewhere on the website I'll put a link similar to the link to Postgres, to the Postgres doco. All right, so these are the critical, and I don't know how often I've used. How would we initialize the DB via Python? Oh, you don't. You initialize it using Postgres, just the way you've been doing. So a lot of the assumptions we're making here is that we have a database and we want to interact with it. How did the database come into existence? We use createDB and we load it up. Might work. System P1, that would start your database server from Python program, but why bother? Do it from the shell and just get your Python programs to interact. I don't know, and I'm not going to. Why do you want to? You've already got a perfectly good createDB command that you can use, and you don't need to do it from Python. System createDB would create a database with may create a database with your name. Shall we try? Let's get out of here. I'm on VXDB. If I run Python 3, do I need to? I got no idea whether this will work. Oh, look, I use single quotes. Oh, damn. System is not defined. Wow, what a shame. Import sys. Thanks. Do I need to say sys.system? I will try without. Great, I don't need semicolon or something. I don't remember. Yeah, well, that, nope. Oh, maybe you can't do it. What a shame. Yeah, I'm sure you can. Good-o. Who cares? Why bother? You know, if I really wanted to do this, I could go and bingo, I've got a database called XYZ. Yeah. Far more convenient. There's no point doing everything through Python. All right. So what was, oh yeah, I wanted to say a little bit about execute and how you insert values. Okay, so the execute takes an SQL statement. It could take a straight SQL statement, or it could take a SQL statement template, which has %s's and things in it, and it could interpolate values into that SQL statement. Now, there are two ways you can get values in. You can't just write a value here. That doesn't work. Talk to the PsychoPG2 developers about that. This weird looking thing here is a tuple containing a single value. The most usual way to interact with execute and supply some values is to use a list. So you've got a list with a single value. When I say execute and run this, it's going to run the query select star from R where X equals 1. So it'll effectively run that query that we've got at the top. If you really want, this is just a string. You could store a string in a variable and then run execute using that string. Notice you could even use a pattern. Oh, and the other thing the other thing that'll make this clear, that's a Python tuple with a single value 1. This is a Python list or array with a single value 1 in it. I wouldn't bother with the tuple version. I'd just use the list version. Probably shouldn't have mentioned it. Never mind. All right, now there was some discussion about F strings and execute on the forum. F strings allow you to interpolate values into another string, but they don't allow you to necessarily do it in a safe way. In other words, people can use SQL injection attacks. Why wouldn't you? I'm just telling you why you shouldn't use the F string, because it's open to SQL injection. So using execute will allow you to interpolate values into your query. That's fine. You probably want to do that. But it will quote things appropriately. Execute checks the patterns that, no, it doesn't. It just puts, what is SQL injection? Yeah. Let's see, can I illustrate? In fact, this is probably worth doing. Import PG2. Alert. Yeah, thank well, drop DB. Select star from students. Oh, what? I didn't need a blooming F string for that, did I? Oh, yeah, I could. Right, where this comes from, an external source. Equals something. Actually, it probably would have been better off using name. I guess it doesn't really matter if you don't ever plan on having external user input. True. But why stick with silly F strings when you've got execute that does the job perfectly well? Let's see. I think I should have done name actually. That's where. I hope that's a valid variable name in Python. What would I know? Never used Python. All right. Mogrify. Why am I doing this? I don't know. Q1. Right, well, I've already inserted stuff in there. Doubt that this is going to work, but now, yeah, it would. Oh, damn. Should have used double quotes, shouldn't I? Mm. Let's chew up and I've got a quote, I've got a tickler. All right, that might do the trick. What? Oh yeah, it would help if I had a cursor. Hmm. Oh, I have to connect to a database as well. You know what? I should have used one of my existing ones. Equals test. I know I've got a database called test. Right, make it cursor, blah, blah, blah. Here's my thing that's been sourced from an external source. Let's see what we get. Oh, no, that's not going to do anything, is it? I need to print it. Well, I might have done something. Oops. Okay, so this query here is simply inserting the string underscore name, which looks like this, into Q1, and then runs that directly. This one here sets up a template and then inserts the string underscore name correctly quoted into here. So let's have a look. Hope by now I've set all the infrastructure up. Oops. Oh yeah, that would have worked. Hooray. All right. So hopefully you can see the difference. This string here has ended up as a select query. Okay, that's fine. But then it also does a delete statement, deletes all the students, and then just to make it syntactically correct, it adds a dummy select at the end. I don't know. I must be magic that I don't need colors. All right, this one here using execute or mogrify, you can see that it's taken that naughty string and it's doubled up the quote here. And all of this stuff is inside an SQL string. Okay, so it's harmless. I don't know what that proves, but I'll leave the code there so you can see how to do it. Don't do it though. All right, if you insist on colors, I can show you one more trick. I think that's how do I know that's it? I can run the command which Python 3 and it'll give me the full path name. Use bin Python 3. All right, what does this thing do? This tells a comment for a start. It looks like a comment, but it's a special one. And if you got a hash bang at the start of a file and followed by a name, it assumes that is the full path name of an interpreter, which can be used to interpret the rest of the file. And if I was to re-invoke this, now it's going to know that it's a Python script and it should color it appropriately. I don't need this. The other way I could tell Vim that it was a Python script is to stick a .py suffix. No, you don't need the .py suffix. I can't. I'm thinking I don't want to get rid of that because, I know. I'll turn it into a real comment. If I then go back and edit that, oh, shit, still knows it's a Python script. Goodness me, I don't know how it worked that out. Maybe it saw this. Oh, well, in any case, that's the way you set files up to be executed. I know what I can do. Get rid of that. If I edit that again, oh, how the hell does it know it's Python? Oh, it knows it's Python because of the dot pi on the end. All right. What is F doing? F is a fancy. I mean, plenty of other languages had it already. Python finally got it. Yeah, basically what it does is it allows you to insert the values of variables or actually expressions into a string by enclosing them in braces. Okay, so this is a special formatted string, if you like. This one I could equally well have used double quotes. Oh, what's that semicolon? Hangover from SQL and C. Right, so this string here is blah, 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 blah. That's all literal up to that point there. Then the value of this expression underscore name will be stuck into the string followed by a literal single quote. Doing it this way, basically this is a string, a regular Python string, which represents an SQL statement template. In other words, a partially complete SQL statement, and Mogrify will take this template and insert this value here, but it will quote it appropriately, whereas this one will just end up being a mess. So F, does that answer your question about what F is doing? What is F doing? What you could do, look up F strings in on Google, Python F strings. Let's see what else. Q1, what do you do? What's your favorite language, Jess? Good question. Whenever I need to just knock off a quick script, I use PHP. I keep saying, oh, I got to learn Python because it does much the same thing, but with less dollar symbols. But who has the time? Yeah. I used to do PHP in this course, and then certain people said, PHP is a crap language, blah, 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 why are you wasting your time? Why don't you use Python? So I did. One rationale for using Python is that I kind of, good guess. PHP is kind of, it's not kind of ick. The only problem with PHP, as far as I'm concerned, is the libraries. The libraries have inconsistent interfaces. Another reason for switching to Python was I assumed that most of you would have taken COMP3311 and therefore have a passing familiarity with Python. So I can talk about, yeah, I agree. It feels a bit inconsistent, and that's mainly the libraries. I quite like the way PHP handles arrays. They're all hash tables, and you can use them either as regular arrays or you can use them like tuples. When you got this, yes, to some extent. Hopefully these examples, I mean, we're not dealing with Python in any difficult sense. And having said that, I'm thinking of the assignment, and some bits of it might require some interesting Python. Anyway, let's start from the beginning and start looking at some examples. Right, so here's, if you want to use CyclePG, you have to import it. This is Python's version of hash include. Well, that's nice. Yeah, Python's version of hash include. Python has exception handling, little bit. No, it's just giving you a pipeline down which you can pass. It's giving you an abstraction that allows you to send SQL to the database and to deal with the results that come back. Would you ever make multiple cursors? Yes, you could. In that crappy example I showed you of how not to do things here, these res 1 and res 2 could easily have been separate cursors in CyclePG2, but we didn't use CyclePG2 here. I'll leave it as an example for you to write that in CyclePG2. Or maybe I shouldn't, because you shouldn't be doing that. Anyway, right, let's get back. Where are we? Oh, yeah. Right, this is the hello world of CyclePG2. Connect to a database, you give its name. As I said, the way we're using Postgres and Python running on the same machine with you as the super user, all you need to specify is the database name. In other contexts, you might have to give a user and a password and a port and things like that. All right, so we're printing out the connection, which gives us this. So basically, this is a Python object which contains a little bit of information. It's got the string that we use to connect to the database, and it's also got a flag that tells us whether this particular connection is open or closed. At this point here, we just opened it, so the closed flag has the value false. And after we close the connection and then print the connection object again, we now see that it's closed because closed is true. Yeah, all right, so exception handling, use the keyword try to start off a block where you want to trap errors, and at the end of that block you put except, and you can put a you can be more specific than what I've done. You can say particular kind of exceptions that you're interested in. Put in the finally clause, yes, yes, yes. I've got examples of that elsewhere. I think this is just aiming to be really simple. So we attempt to make a connection to a database called test. And if it's successful, then we'll have a connection object, this one here. We print out information about it, we then close it. That changes part of the state of that object. If this fails, then that'll throw an exception, which will take us down to the exception handling part. And we'll capture the actual error message in this variable, and we can actually print that out if we really want. So you always put it, yeah, all right, yeah. And you can actually have after that, I think it was EX1. Yeah, so that's that. So I can execute that. Oh, and I'll show you something else than that. All right. So it opens a connection to the test database and then closes it. All right, that EX1 file is executable. EX1.py doesn't have to be executable because you run it by typing Python 3 EX1.py, and Python 3 is the executable and EX1.py is just data to that. EX1 and EX1.py, I think, are almost identical. All right, except EX1, I've added the hash bang at the start of the file, so it knows which interpreter to use. Now, if I wanted to be silly, I could change that to bin shell, and then the script wouldn't work very well because it would try to interpret the Python code as shell. All right. Oh, yeah, you were talking about. Let's now start making them different. Ooh. Tabs. And I guess I could have taken these. Here, I don't need to close it again. So finally, whether you get an error or whether you successfully do everything you wanted to do with the try clause, try section, I don't know what you call it. Whether you do the try or whether you end up in the except, then after doing all that stuff, you can close the connection. So that's what the finally clause does. It basically allows you to clean up. The other thing that we can do here is I think we can print E. Now, this is going to be a bit boring. Close what? Closed is 0. Closed is still 0. Did I put that print in the wrong spot? Something that you oh, thank you. Yes. Who's talking? You're not very loud. I'll turn my output up just in case. Yeah. Yeah, so I wonder why it didn't throw an error for using close with them. All right, so now it's closed. So try except finally would be standard structure for fiddling around with the database. One thing I should show you, what's an error, pick a random database name. Hopefully I removed that database called XYZ. that I created before? Yes, I did. Right, so if I try to run this, I will now get an error. Fatal database XYZ does not exist. So that's what E is. And then I get all this other crap that Python likes to give me to help me with my debugging. Okay. So yeah. All right. Now that's all very nice, but I'm not really fetching anything from the command line, but I'll take a look at that in the next example. And put it back to test so it doesn't fail. And you can kind of argue that finally is not not essential at the level of the main program because it's going to exit anyway. Oh, and here I've put in the explicit exit just for fun. Not sure why I did that. All right, so here's another example, a script that lists all the subject codes and names from the assignment 2 database. So I've got a script for that. All right, it's got the hash bang at the front. So it executes a query using execute. The query is nothing special. Why no beer for assignment 2? I think we've done beer to death. In assignment 2, you're going to learn all of the gory details of your degree structure, which might help you graduate on time. All right, so running a query using execute. So here that sets up cursor so that cursor the cursor object has access to all of the results. And here we're fetching them all, giving us a list of results and iterating through that list of results using a for loop and printing out each of the results that come back. Probably should have used a smaller example so that we could actually print out fetch all. Anyway, let's so it prints out all of the courses that are stored in the database in some kind of random order. What's fetch all doing? It's actually fetching all of the results from the query, putting them in a list, and then we're iterating through that list and printing out each tuple as a tuple, in fact, which is why it's got the parentheses at the start and the end. So that's how Python displays tuples. Yeah. I might pick a simpler query. I think that test database has got some small tables. It's also got, all right, let's see what X has got. Yeah, that's probably okay. Is Y smaller? That's kind of similar. Right, I'll use X. Use shriek dollar there. Da, da, da. test, select. Table called X. All right, first thing I want to do, what's the benefit of implementing in OO structure rather than procedural function? Yeah, beats me. Python is an OO language, so that's what we have to put up with. I mean, OO has some benefits. I've got to admit that. All right, so let's start by doing a print of the whole return. So this is just so we can see what it looks like. And then we'll iterate and go tuple by tuple. Okay. Simple, it had, oh, gee, it ended up being 755. What a miracle. What is OO structure? Hey, why didn't it? Oh, because I already fetched everything. All right, interesting. I'll have to update, yes. So object-oriented is a style of programming where you view the data as a bunch of objects where each object contains information and has methods that act on the information contained. So what can you print? Cursor execute, I can try. All right, a couple of things to notice here. So you can see that it's a list or an array of tuples. So that's what comes back from fetch all. Is like dot something that's characteristic of OO stuff. Yeah. Am I still editing? No, I'm not. All right, so we open the cursor, blah, blah, blah. Oh, yeah, so I print, oh, you wanted to try and print that. All right, why not? Just for fun. One thing to notice though, so it printed the results I got back from here, and then it invoked fetch all again and would have iterated through it. But because I'd already finished the query by doing this fetch all, there was nothing else left in that cursor to fetch. Here's the code, Maria, if that's what you wanted to see. Right, yeah, so getting back to the object orientation, how did we have tup without declaring it? Magic, magic. You don't have to declare variables in Python. You could have asked the same question about DB and cur. Where did they come from? Well, you're all surprised by this Python stuff. All right, let's see what it prints for that. Ah, all right. Can't print it. Doesn't know that it looks like a printable thing. Because it was what? Equals. What does that mean? Are you happy that, yeah, it printed none? Because this in itself doesn't give you a return value. It just executes the query. And if you want to think of it this way, it stores the result inside the cursor object, and then you can extract stuff from the cursor object by using fetch all. So that's why I printed none. All right. And yeah, the reason it's not printing, the reason it's not running through the for loop is that it's already fetched everything at this point, and the cursor is at the end of the list. And if you, well, it's already exhausted the query. And if you try to get all the results again, there's probably a way to reset it to the start of the query. In fact, I'll tell you one thing you could do. Do this. I could do something like that. So I've fetched all the results, stored them in a variable called results, which is a list of tuples. I can then print that out, and then I could also iterate through that list because it's stored somewhere. Oh. Oh, yes. Good on me. Not used to this Python colon business. Yeah, thanks. All right. So here's, if we just print the results, we get the list of tuples. If we iterate through that list, we can then get a tuple at a time and do stuff with it. All right, hopefully that's clear enough. Ooh, 6. All right, let's get back to that subject thing. Okay, so here, you know, we've got this function that returns a list of tuples, and we just stick that as an argument to the for loop, and it iterates through that list. I forget what I had a whole sequence of these things. What does this one do? Oh, yeah. All right. This is to show off multi-line strings in Python. So if you have to write a big query, you can do it like this. Triple quote starts a multi-line string, triple quotes ends it. So it's just a string. You know, it's kind of like those dollar strings in Postgres. And then we can execute that query. The only difference I've made here is that I'm ordering by the course code. If you think about the sub, the courses came out in effectively random order. I could have done that as a standard string on a single line with one lot of double quotes at each end, but I decided to show that off. All right, let's see. /2. And now we get it in alphabetical order on course code. All right, looking at an output of a bunch of tuples isn't that exciting. So let's have a look at maybe formatting each of those tuples a little better. So here's the same query, executing it. Oh, I guess that's the other thing I should have shown, yeah, that I'm executing the query string because I've stored the query string in a variable. Here, what we're doing, we're running through the list of tuples. For each tuple, this is one thing that's quite nice about Python. I can extract the components of a tuple simply by writing variable names on this side separated by commas. And if the thing on the right-hand side is a tuple, if it's not, I'm sure it will complain. But if it is a tuple, it will take the first element of the tuple and stick it in the variable code. It'll take the second element of the tuple and stick it in the variable name. So now we've got variables containing the components of the tuple, and then we can stick them into an F string to print them out. So this is a variable holding a string. Here we're sticking the value of this string variable into the output string. There are probably other ways I could have done this. Why do we need to put in an F string? Indeed, I was just wondering that myself. Maybe anyway, I'll show you what this looks like. Oh, it says permission denied. Why does it say that? Because sub 3 is not executable. And then I get the tuples looking slightly better. Yeah, I did the chmod. Why do we need to put it into an F string? Maybe we don't. Let's have a go. Who knows how to do string concatenation in Python? I have a funny feeling plus, yeah, I thought so. That what I could do, maybe, if I'm lucky, still on a space. Gosh, I've turned into a single quote man. Thank you, SQL. Let's see if that works. And indeed it does. And just do the variables, comma separated. Ooh, that too. Wow. Wow. All right. Might stop right there. I might just put the F string back as an alternative. What about the next example? Oh, don't you have to go somewhere? Oh, I'll do that on Thursday. I know, yeah, you want to have a look at how we, all right, no, I'll do it. I'll quickly have a look at it now. Yeah, double quote and single quote, pretty much the same. Print code. So this is an alternative for the line below. And as someone said, you can just write the names separated by commas. I think that may work. I wouldn't live or die by it. All right, so subject 4, right? Let's start /sub 4. Let's find all the tally examples. So you can put in part of course code and it will give you all the courses matching that code. All right, how does that happen? Clearly we have a command line argument. So somehow we've got to get that into our program and we've got to get it into our query. Right, so now the program becomes a little bit longer. All right, so we need to import the sys module, which gives us things like argv and argc, which you get automatically in C programs. But anyway, so we can work out the length of something, length of a list by the function len, which notice doesn't require a dot. But accessing argv does. It's a component of the sys module, if you like. So we can work out how many command line arguments there are. If we don't have at least 2, then we write a usage message. Notice that here we're using an F string and we're interpolating the result of an expression, just getting the first element of the argv list. All right. So if that doesn't work, we call exit and we give up. We then go into a try section where we try to connect to the database. We try to make a cursor. Potentially that could fail as well, I guess. And the way we do the query is we want to interpolate the command line argument, which is the subject pattern, so tally that I typed before. So we set up a query template, which has a slot into which we can insert a string. And then we execute the query and we make an array just containing the first command line argument. And we know there is a first command line argument because we checked that up here. And then we execute the query. So it's looking for subjects where the code matches, Perl regular expression matching that. The string, which is the command line argument. The reason I didn't use like is if I want to use like, I have to stick percents around it to make it work easier, to make it work at all. But here I can just insert the string itself. All right, and here's the same stuff that we had before. So new things about this, using the sys module to look at argv, and we just look at argv. We don't have to look at argc because we can work it out from the length. So getting access to the argv object, which gives us access to the command line arguments, and taking one of those command line arguments and interpolating it into an SQL query template. Should it be tilde star? Yeah, if you want. If it's not tilde star, then I have to type the partial string with, oops, in the correct case. Now I don't, I could just type tally in lowercase and it should still work. Yeah. Whereas the original version, that wouldn't have worked because tilde by itself is case sensitive. Was that everything? Yep. Oh, I didn't have it. I didn't have answers for those upcoming examples. So I'll write him in the next thing, and in the next online session, I might take a look at the database for assignment 2, because there's some subtleties in that database. All right. I'll see you on Thursday. Closing recording.